Now, guess what? We're going to do the same thing, but now we're going to have those squared things thrown in there to factor. So, again, I have a fraction divided by another fraction. I'm going to invert and multiply. So the top's going to stay the same. 3x minus 6 over x squared minus 25. The bottom I'm going to flip. X minus 5 over 15. I'm then going to look to see where I can factor. On the top of that first fraction, again, that's one without the squared, so I look for my greatest common factor, which is 3. I can divide a 3 out of each of those. So 3x divided by 3 is just an x. 6 divided by 3 is 2, so I have 3 times my x minus 2. On the bottom of that first fraction, that has a squared term. I know I'm going to have 2 sets of parentheses. I hopefully recognize it as the difference of squares, but if not, I just factor it like I normally would. X and x. The end is negative, so we have 1 plus and 1 minus. Factors of 25. 5 and 5, right? And then here we can't factor, here we can't factor, so we're done with our factoring. We're going to go to our canceling. We can cancel out the x minus 5's, right? We can also reduce the 3 with the 15. 3 goes into here once and into 15 5 times. So on top, the only thing we're left with is the x minus 2, because we don't need to write 1 times x minus 2. On the bottom, we have the 5 and the x plus 5. So 5 times x plus 5. Number 11, same kind of thing. I'm dividing my fractions, so I'm going to leave the first one, 5x minus 15 over x squared minus 4. I'm going to multiply by the reciprocal. X plus 2 goes on top. X minus 3 goes on the bottom. So on the top of that first fraction, I can divide those both by... No, 5. You always want to get the answer first. The 5, and then I'm going to have x minus 3, right? The bottom has the squared. I know I'm going to have my 2 sets of parentheses. How's that one going to factor? X and x, plus and a minus, and then our 2 and our 2. We'll get to the 2's. Second fraction, there's nothing we can factor out. I don't have any squareds and I don't have any greatest common factors, so now I can just go to my canceling. I can cancel out the x minus 3's. I can cancel out the x plus 2's. That doesn't leave me a whole lot left. On the top I have a 5, and on the bottom, an x minus 2. All right, go ahead and try the next one there. So the top of the first fraction, it's the difference of perfect squares. They just have the things switched around from how we're used to looking at them. But we don't want to switch the order. We just want to leave it alone, put our two sets of parentheses and factor it like we normally factor. So we're going to factor the 49 first. 49 would be 7 and 7, right? My signs, 1 plus and 1 minus, and then the x squared, x and x. Bottom we can't factor. It doesn't have a squared, doesn't have a common factor. The top only has one term. We're not going to do anything with that. But the bottom we can factor. Both of those are divisible by 3. So we're going to put the 3 in front and we're going to divide them each by 3. Again, we're not going to switch them around. 21 divided by 3 is 7. Negative 3x divided by 3 would be a minus x. Not a lot of canceling we can do there. The only thing I see that we can cancel is what?
The 7 minus...
The 7 minus x. There's nothing else there you can cancel. The 4 and the 3 don't reduce. I can't do a one-term thing with the two-term thing. And so my answer is that I have 4x to the 7th times 7 plus x up on the top. And on the bottom, I'm going to have a 3 and a 4 minus x. So as crazy as that looks, that's going to be my answer.